Welcome and thanks for attending. I'm looking forward to this. This has been a subject of mine that is I get very passionate about. So I hope you feel that throughout this presentation. My name is Craig Campbell. I am uh, I'm the division manager and lead architect for eProcess 360, which is a division of West Coast Code Consultants. I've been in the software industry for 12 plus years and have had experience in lots of different aspects of software design, software development. I started off as a DevOps engineer, moved into the front end with .NET and WPF, and then ended up moving into the full stack or web development arena just within the last few years, and it's been awesome. I've been playing around with all sorts of things from electronic documents and web airline reservations to coding up the UI for the Predator drones. So it's been a fun experience. The bulk of my experience has been desktop, and within a desktop environment, there's a lot of different things that make it really fun environment to work in. You're in a single process runtime environment. You've got a single memory space. All of that stuff allows you to work pretty much as you want. There's no restrictions or very few restrictions. And one of the pieces that I really loved was the UI events and the observable pattern. And so when I moved from desktop into the web arena, although we have events on the client side, and yeah, we do have server side events, but the one piece that I really missed was that UI event driven architecture. And then we found PubSub, and PubSub has been awesome, at least for me, because now we have the ability to go through and drive our application through events. So the next piece that I will show you is our application that I've been working on over the last several years. When given the opportunity to create my own application, after my years of experience and work with this, I finally got my opportunity to create my own. And so eProcess 360 is a web-based, cloud-based permitting system that is pretty simple in form and function, but allowed me the opportunity to work through a lot of things. So I took an existing application that was a monolith application and just blew it apart. And we went microservices back end, we went micro front end on our front end. We write in Node.js. Our primary language is Node.js and React. But this is where the microservice and the micro front ends come into play. What we can do is we can use the appropriate language for the job and the task. So if our backend service requires .NET or Node or Go or Rust, we can write the language or write the task in the appropriate language. Same with a front end. If a front end framework that we like is better than another one, we can migrate to that one, and we don't have to upgrade the whole app in and of itself, right? We don't have to start and rewrite everything in the new language. And so what does that do in terms of PubSub for us? Well, that allowed us to communicate, to keep our communication across, again, the several microservices and the several micro front ends. One of the other things that we were able to do is, because we use Docker, and we containerized all of our web servers, and our services are all done in a Docker container. So our deployments are very simple, very straightforward. And then, like I said, the backbone of our communication is the PubSub framework, or the PubSub event broker. And so that allows us to communicate with not only client side, but server side, and then interest services as well. So in between the services, they can do that. So just a quick kind of demo, or not a demo, but a diagram of what we're looking at is, again, many disconnected services. So we have, we can stand up services as needed. We can scale those services. We can move them around. We can put them in different regions. We can work on different things. And likewise, with our micro front end pieces, we end up with, again, many disconnected front end pieces. So all of these pieces let us work together. So what I'd like to do is give you a quick demo of the overall application, and then we'll talk a little bit more about that afterwards. This is eProcess 360. eProcess 360 is a permitting application that is built using workflows. We do all types of workflows. Building, planning, public works, code enforcement, fire, and business licensing are just a few of the ones that we do. There, you can build just about any workflow you want out of it. It's a straightforward workflow building and management system. So what you're seeing at this point is our GIS portion mixed in with our project management. And I think the important part is to take a look at this. We have 3 different applications running, web applications running. So the first one is my header bar. That is an entirely separate app than my home app, which is this content. And then the footer app is a separate application as well. The idea being that we can separate, we can do parallel development with teams if we need to. We can update one and not have to work on it, deploy it, and then only work with the piece that is changing. And so that's what you're seeing, and I'll point out all of the different ones. But right now, all of this information is being run over events. We subscribe and work to topics. So the communications that you're seeing is all EDA. One of the aspects of it is, let's jump into a workflow. So right here, we're in our solar permit workflow. You can see they've progressed to the permit fees and are pretty much on reviews. So let's jump back here and take a look at the application form. The application form is made up of some sub-steps, but the interesting thing about this is that these sub-steps, even though, again, this just follows a normal workflow application, there really is not anything special about what we're doing, but where we can go with it. So right now, if I click next on this, all of this information that's contained within this form is going to be uploaded to our storage, right? Our database. And then it will be stored for later processing and retrieval. But what can happen is, because we send an event, if I want to do some middleware processing on this or some parallel processing and take the information that I give and try to do something else with it, I don't have to know about that chain of events beforehand. I hit submit. The next thing that happens is storage gets it and it stores it in my database. But I stand up a separate processing unit and it'll jump, or service, and it will jump out and say, hey, I'm interested in that event, and I'm going to pull that information and then I'll process stuff. One of the best examples I have is this guy. So when we submit plans, there's a lot that's contained within those plans. Information of types, what work is going to be done, what inspections are needed, what permits might be needed, what reviews might be needed. So all of that is contained within those plans, and yet we're gonna ask the either the contractor or the staff to read those plans and build these reviews themselves, or the inspections or the permits. So what we've just done now is we submit it and it goes into our storage mechanism, whether that's cloud storage, Google Cloud, OneDrive, Dropbox, Laserfish, whatever's configured, their configured storage is on this, it'll obviously go there. But let's stand up the middleware, the other piece, the processing piece, and we're going to use AI. So we're going to get into AI. AI is going to say, hey, I'm interested in that document. It's going to pull that document, read that document, and then it's going to add any additional fees that may be needed. It will add any additional reviews that may be needed. It will add any additional permits, issuables that might be needed, and any inspections, so that when I drop into, say, the inspections tab and I can see what's going on, rather than having the one that the city says, we know we're going to need this one. There might be others, but we'll have to build that at after we've reviewed the submitted documents and read the submitted form. Now our AI processor can pick it up and tweak it and start running with it. So that's just one of the potential benefits to EDA, that we can stand that up and not have to touch anything else. So let's get back to the presentation, and I'll walk through some of our behind the scenes looks and see our client to server communication, as well as some of the potential benefits that we have going forward. Okay, now that we've seen that, what I want to talk about is a little bit behind what goes on behind the systems. Now, I will reference Aaron Lee's 2022 EDA Summit talk. It was one of those things, when I saw his Singapore bus demo, that blew my mind. I was so excited with what we could possibly do. And then finding myself in an arena where we deal with jurisdictions, we deal with cities and counties and states. And so I have an opportunity to take a look at a little bit at what we have, what we can do with this stuff. So it was fun to see that. And we do use smart topics quite extensively through our system. Like I said, EDA is the backbone of our system. And so we're looking for clients who are publishing the topics, and when they publish that topic, then the service again can spin up and take that event, either process it and kick out new events, or respond to it. And so again, we don't use much REST. We're primarily on this because it just gives us a very easy way to, again, scale and to work through different things. So one of the other things that I like is the queues portion of it. Now, queues solved a critical issue for us. We do want to scale, and one of those scaling activities is, how do we handle the same message, across multiple, or how do multiple services handle the same message across, so that we're not either double processing or triple processing. And so adding the queues to the system presented a really nice solution to that. We were able to, we can scale up our services now. Like, well, if a project does, 10,000 creates, because we have that many clients running through our system, right? And they're all creating new projects, we could easily swamp a single server. So we create this work, and then the queue handles, again, the microservices queue handles all of that, not the microservice queue, the queue handles all of that work, so that the service doesn't have to worry about doing that as well. And then where this really came in to play was, we were, as part of any service, especially government service or any service that is, they want to track the auditing. They want to audit what is going on in their service or in their application. We could have gone through and created a logging or an audit call and made those calls out to the service to track what we're doing. What that would have done is we would have modified probably 50 different services to do this work. But instead, we follow the open close principle. I don't know if you're familiar with solid principles. The open close principle is open to extension, right? But closed to modification. We don't really want to modify existing services. When you modify an existing service, you have to regress that service. So you're taking time away from your QA or test department, test teams. Then you also have to deploy that. So your DevOps teams are now responsible to deploy all of those pieces that have changed, even if it is not a functional change and it's just a logging change. You should still regress definitely regress, and you'll definitely deploy. So those are the two pieces, and that's what this audit service was able to give us. So we stood up our audit service, we subscribed to all of the events, we pulled and categorized those events, and did the business logic to pull out and analyze and perform analysis on those logging pieces. And we only did it with one service. We did not touch the other 80 services that we have in our system. And so we really did. We took full advantage of the possibilities that we have with this. One of the other aspects that we are also in the demo, you saw that we do automate a lot of our tasks, and some of those tasks and those automations come because of these triggers and actions. Now, this is just straight up pub sub. Our triggers are the publishers, our actions are the subscribers. And we, like I said, we use event or smart topics throughout the system. So doing this presented something that I don't even think we had within desktop applications, right? Is now both the client and the server could subscribe to the same trigger. Now, when they subscribe to the same trigger, now that doesn't mean they're doing the same work. The server will end up doing the processing and that portion of the work, while the client, who also subscribes to that same event, will end up doing maybe something different. They can either detect that the change has been made and go pull, or they might throw up some visual feedback that work is happening and that we can see it. Or, and this is where I'm really excited about it, is when the server gets done processing, it just pushes another event out, and that's what the client is subscribed to, and the client can then work through, and he doesn't have to worry about polling or checking to see if there's anything he needs to do. He gets what he's supposed to do and then works on it and is done. And so really excited for the triggers and actions portion of our application. Finally, what we have on the roadmap is really exciting. We've seen it in other aspects. We've seen it in Google Docs or Office or Excel, or I guess that's Office. But we've seen it in many of the other things. So where we have real-time collaboration, multiple users working in the same space, and you can see what's happening. Well, we want to bring that to our app. That's going to be new to us. We're going to bring that to our app and allow teammates to work through their workflows together, even though they may be in separate, working from home, working in the office. The review portion of the application is going to really take off. Reviews follow this scenario, right? We get the plans from the architect or the engineer. Our plan reviewers, our structural engineers, will review that for code violations or how to change it to match and meet the code of the state or the city. And then they will create a comment letter and then send that back to the architect or engineer. And then they will make the changes that are requested and then send that back to our reviewers. The reviewers will do it, and they could be back and forth a couple of times. Well, this can take days and sometimes even weeks, depending on how long it takes to make those communications. So with that, we're going to introduce chat and the collaborative sessions. So now the plan reviewer can work directly with the architect, and rather than days of delay, we could be done in a few hours. So we can speed up the overall efficiency of the city through this. Same idea with inspectors and inspections, right? The inspector doesn't have to wait until they get back to the office to ask a question. They can chat directly with their counterpart here, at the plan reviewer. And so we're looking forward to that. But really what's exciting, and this is the nod to the Singapore bus example, cities, like I worked in the oil and gas industry, and we had power plants and plants that would have thousands of sensors that we would have to track. Cities are in that same boat. Traffic signals, traffic density. You're looking at traffic signals, cars on the road. I mean, we can start pulling all of this data from these different spots, different data sources, and start combining them into an overall planning service for the city. Right? We can track buses, which you've already done, which Solace has already done, and we can track garbage, track fleets, track crews, work on signage, putting all of this in place so that the city planners can actually start planning their cities. So event-driven architecture allows for all of this to work, right? Disconnected modules working as a single piece, allowing us to prepare for extension without modification, right? Let us scale up or add new services without having to go back and fix the ones that are there, just to do something that could have been done without it. And then obviously real-time collaboration is one of the big, but that's the beauty of it. It's a piece, it's not the piece. So event-driven architecture really allows us to explore what we could do in a much bigger platform.